Welcome to this session on mastering asynchronous JavaScript. I am Karan Kumar, and today I will break down one of the most important concepts in JavaScript, which is asynchronous programming. JavaScript is single-threaded, meaning it runs one task at a time. But in the real world, we often deal with some time-consuming operations like fetching data from APIs, reading files, or handling user interactions. If we wait for each task to complete before moving forward, our application would feel slow and unresponsive. That's where asynchronous JavaScript comes in. And in this session, I will explore callbacks, promises, and async and await. And to make things even better, I have also attached some demonstration code in the PPT. So let's dive into it. So the very first question is, what is asynchronous JavaScript? As I have already discussed in my introduction that JavaScript is single-threaded programming language and it executes synchronously by default, meaning every task wait for the previous task to finish. But some tasks like fetching data from APIs and reading files take some time, and we can't simply block our main execution, main thread of the execution, right? So in order to overcome that, JavaScript provides asynchronous nature, means it executes code parallelly without blocking the main thread, which makes our applications feel faster and more efficient. Now we will see through the code how asynchronous JavaScript differs from synchronous one. So synchronous execution simply means executing code line by line, means every task wait for the previous task to finish. But in the asynchronous execution, the code runs parallelly without blocking the main thread, right? So in the left hand side, we can see the example of synchronous execution. Here, for first of all, for printing anything in the console, in the JavaScript, we use console.log. Okay, so in the left hand side of our code, we are printing task 1, task 2, and task 3 in order. And if we run this code, then we will get output like this in the same order that we have given in the code. Okay, now coming to the right hand side of the code, there are three pieces of code. The first one is printing start, and second there is one set timer function. So set timer function is basically an asynchronous function which executes after 2 seconds of time. The time that mentioned here is 2000 millisecond, which is converted into 2 seconds. So that's why this set timer function would execute after 2 seconds of time. Okay, we will discuss about it in the further slides. And in the third piece of the code, it's printing end. Now, when we run this piece of code, then we get output like this. First of all, we'll get start, then end, and then async task done. It's surprising, right? Because async task done is written before the end, but still in the output we are getting end before async task done. That's the magic of asynchronous JavaScript because the set timer function will execute after 2 seconds of time. But our code is not waiting for this set timer function to execute. Instead of that, our code is printing end, right? So that's how asynchronous execution works in JavaScript. Now we will study the basic fundamental of asynchronous programming, which is callback. A callback is basically a function which is passed as an argument to another function, which is basically used after the task is completed. uh, Callbacks are used in event listener, set timeout that we have already seen, and there is also one set interval and async operations. Okay. Now we can see through this code, example code, that there is a function called greet, which takes two argument, a name and a callback. Name is basically a string and callback is basically a function. So inside this function, we are printing hello, comma name. Okay, and we are also calling the function callback, which is passed as an argument. Uh, and there is one another function, say good morning, which prints good morning to the console. Now we are calling greet function, and we are passing the string Karan and a function name. Okay, like that we have discussed that this greet function would take two argument, name and callback. So here name is Karan and callback is say good morning, right? So the output of this code will becomes in the console we will get hello Karan and as in the greet function, callback is called. So say good morning will be called and good morning will be printed in the console. Okay. Like that, we can also see through the set timeout example. We have already seen this example in the previous slide, but for explaining callback, you can see set timeout is a callback function. It's a callback function where we are passing this function as an argument, comma 2000, which is a time. Okay. So the output of this code will be something like this before timeout and then after timeout, and after that it will print executed after 2 seconds because of the asynchronous nature of set timeout. Now we will discuss about one major problem of callback, which is callback hell. Though we know that callbacks are the basic fundamental of asynchronous programming, but still, when they are deeply nested, they form pyramid of doom, which which makes the code base very difficult to uh, read, understand, and maintain. Here we have used only four functions, but still this code is looking bad, and it's very difficult to understand this code. But when we use 1,000 lines of code, then it's very difficult for a developer to read and understand the code base. So the solution of this problem is promises and async and await, and we will take a look on these two in the further slides. But first of all, take a look on this code. So here this shows a callback hell. So there is a set timeout function which is printing step one and again invoking another set timeout. So the first set timeout will execute after 1 second of time, and then the second set timeout will execute after 2 seconds. Means total 2 seconds. It means after printing step one, the set timeout will be invoked. So the step one will print after 1 second. So after 1 second, the second step set timeout will invoke. So the step two will print after 2 seconds. Similarly, step three will take 3 seconds of time, and step four will take 4 seconds of time. Okay. So the solution of this problem is promises. Promises gives us a better way of handling asynchronous code. A promise is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. Unlike callbacks, promises helps in achieving uh, much cleaner, cleaner code, cleaner and maintainable code. Okay, for handling asynchronous functions. A promise can be in one of the following three states: pending states. Pending state, which is the initial state of any promise, and the second state is fulfilled, which states a successful operation, and it means that our promise got resolved successfully. And the third one is rejected state. It means that our promise uh, is rejected. Okay, it means operation failed. Now we will take a look on promise chaining, which helps to avoid callback hell that we have faced earlier for executing asynchronous operations sequentially. Uh, Here comes an example code of promises. So you can see I've already told that promises are the objects. Okay, so in order to create promises, we use this type of syntax: new promise, and inside of this we pass a function which has two arguments: resolve and reject. And on certain condition, we can either resolve it. We can either resolve the promise or reject it. Okay. Now in this example, I have created a variable named my promise, which is a promise object, and it's simply so inside of this there is a variable named success which is already set true, and there is a set timer function. And inside of this set timer function, there is another function which checks if success is true, then it simply resolve the promise. This is the way of resolving any promise. Resolve, and there is a string promise resolve means resolve with a value. And if success is false, then it simply rejects it with a value promise rejected. And this code execute after 2 seconds of time. And when we run console.log my promise, and so it's the initial stage. And so in the console, you will get something like this promise, and you can see promise state is pending. Means the current state of promise is pending because it's initially launched, and this promise will be resolved after 2 seconds of time, as we have already discussed in the code. Like set timer function will execute after 2 seconds of time. So after that, this resolve will be called and this promise will be resolved. Okay, resolve with the value promise resolve. Now uh, we can do promise chaining like this, means my promise dot then. So there are three things: then, dot catch, and dot finally. Dot then will execute when the promise get resolved successfully, and dot catch will be executed when our promises when our promise is rejected, right? And dot finally will be executed every time, whether our promise fulfilled or rejected. Finally will always be called. Okay, so in this example, my promise dot then, and you can see there is one another function which has an argument message. So basically here our promise got resolved with value promise resolved. So that's why in order to get this value, we take message as an argument and simply print console.log message. Means if our promise would resolve successfully, then it will print promise resolved, right? And if there is some error, then it will go to the dot catch. It will simply ignore dot then and go to the dot catch and simply print the error, means the error value that we will get through the promise. And dot finally is that piece of code that always execute. So operation completed will always executed whether our promise got fulfilled or rejected. So in summary, if our promise got resolved, then it will go to dot then code block. And if our promise got rejected, then it will simply execute dot catch. And dot finally always execute whether our promise is fulfilled or rejected. Dot finally will always be executed. Now we will see promise chaining. How promise chaining avoid callback hell. We have already seen how callback hell is created and how it's very difficult, how it's make our code very difficult to read and maintain. Now we will see the solution of that problem through promise chaining. Here I've created one variable called sub closed, which is false. Basically, I've given example of SOP. So there are basically four steps involved in placing any order. Means executing any order, placing order, processing payment, packing order, and finally shipping order. And finally, we'll get order successfully delivered. Okay. So these are the five states that I have implemented in this example. So there is a function called process order, which takes two arguments, step and time. Step is basically in which state our order is currently in, and time, how much time it would take to complete that step. Okay. So this function return a new basically it's return a promise, and it will execute after the time that we have given in the that we give in the argument. Okay. So this settlement function would be executed according to the time that we passed to the argument of this code. Okay. And if stop is closed, if stop closed is true, then it simply reject, means the promise got rejected, rejected with the value stop is closed, cannot process the order. And if the stop closed is true, then it will print uh, the the step completed and then resolve again. Basically it resolved it. Okay, resolve the promise. Now you can see the promise chaining here. It's calling process order function with arguments placing order comma 1000, means placing order would takes 1 second of time. And as you can see, this function is returning a promise, so process order is a promise, so we can apply dot then, and as it uh, as it fulfilled successfully, it will go to dot then, and this dot then again calls process order function with arguments processing payment and 1500 millisecond of time. So this process order is, so this will again be a promise. So we can again apply dot then here. So you can see we have applied dot then, and in this dot then again we are calling process order function, which is returning promise. So again this one also becomes a promise. We can also apply dot then here, dot then in the next step. Now in the dot then here, again we are calling process order function with argument shipping order and time step the time step of 2000 millisecond, and simply in the finally we are printing orders successfully delivered. Okay, and if our promise got rejected, then it will simply go to the catch statement and print console.error, the error message that we have given through the promise. Means shop is closed and we can't process the order. You can see the output here. It executes sequentially that we have given through the code. But for observing the time, you need to run this code in your own environment so that you can get the feel of uh, the execution time of each sentence. All right, we have understand promises and promise chaining, and now we'll take a look on a more modern and elegant way of handling asynchronous code through async and await, which makes our code look like more readable and maintainable, and it also behave like a synchronous code. So how it works? It We use async keyword for making any function asynchronous, and an asynchronous function always return a promise. And we can use await keyword inside any asynchronous function in order to pause the code execution. Keep in mind, it pauses the code execution and not blocks the main thread. We will take a look on this through an example so that we will understand in a better way. So I have taken the same example that we have did in the previous promise chaining. So you are familiar with the function process order and this variable shop closed. Now, in the right hand side, you can see another function called execute order, which is an async function because async keyword is used here. And here it's wrapped inside a try catch block. Um, Basically, try catch block helps in error handling in the JavaScript. We will take a look on this error handling in the further slides. But for now on, assume this it helps in better error handling. Okay. So inside try block, we have four await statements. So the first one is await process order, placing order, comma 1000. So it's the same thing that we have did through the promise chaining. We In the promise chaining we have used dot then, but here we are using await. So what this await do? It pauses the code execution until this promise is resolved. So process order is a promise. So the next line of this code will execute only if if the first promise got resolved successfully. So the first promise will resolve it after 1 second of time. So after 1 second of time, the second line of the code execute. Similarly, after 1.5 second of time, the third line will execute and it goes further. And in the final line, we are printing order successfully delivered. So this is doing the same thing that we have did in the promise chaining example. Okay, you can run this code and take a feel of how uh, the time execution works. Okay, and in the catch part, if any error comes in this try part, then then our code execution will simply go to the catch block and it will print the error that we have received. Okay. So this async and await make our code more readable and easier debugging. Now we will take a look on promise.all method with async and await for parallel execution. So till now, we will understand this better through the example, but before the example, take a look on some theory part. So promise.all runs multiple promise in parallel and waits for all of them to resolve. So basically promise.all helps in running the promises parallelly. Instead of running one by one, we can run our promises parallelly, and it returns an array of result when all promises are resolved. Means we pass all the promises through array, and it also gives the result as an array. Okay, and if any one of the promises fails if any one of the promises fails, the entire promise at all will fails with an error. So suppose we have given 10 promises to this promise.all method. Okay, now, if any one of the promise got failed, means got rejected, then the entire promise at all will fail, okay, with an error. So the very uh, next question comes to our mind is when to use promise.all. So promise.all used in a situation where you have independent tasks that don't depend on each other, and also when all tasks must be completed together and failure in one should stop execution. It will also help in fetching multiple APIs simultaneously. Now we will take a look on the code and which helps in the better understanding of this promise.all method. So again, I have taken the same example in order to maintain the you can say feasibility of this presentation. This process step, which is similar to the process order function, which is taking a step and time and simply resolving according to the stop close variable. Now, in the right hand side, you can see one function called process order, which is an async function, and it's wrapped inside a try catch block. And here you can see a results variable, and which is awaiting a promise.all. So here we have used promise.all, and inside of this we are passing an array of promises. So there are three promises. Now, if we are doing promise chaining kind of thing, then this all three promises will be resolved after 2 plus 10 plus 5, 17 seconds of time. But if we use this syntax, means basically if we use promise.all and pass all the promises and as an array, then all the promises will start executing parallelly, and all the three promises will resolve after 10 seconds of time because it started executing parallelly. So after 10 seconds of time, all the three promises are resolved, and after 10 seconds of time, only the result will resolve successfully. And in this meantime, if any one of the promises got resolved with an error, then the entire result will become will give error. Okay, so it will go to the console.error part, catch part. Now we will take a look on comparison between promise.all, promise.trace, and promise.any. We have already discussed about promise.all in the previous slides. Uh, Now we will take a look on promise.trace and promise.any also. So promise.all helps in parallel execution of all the promises, and it resolves only when all of the promises got resolved successfully, and it rejects when any one of them fails. Okay. Now coming to the promise.trace. Promise.trace resolves when any first promise that settles. Here settles means either resolved successfully or rejected. Okay. Now it's different from promise.any. In the promise.any, the promise.any resolves only when any of the first promise that resolved successfully. So it ignores the rejected ones, which is different from the promise.trace because promise.trace also considered the rejected promise. But in the promise.any, it will resolve only when any of the first promise get resolved successfully. Now we will talk about the use cases. So we can use promise.all in a situation where we have to run multiple dependent tasks, and we can use promise.trace in the situation where we have to receive the fastest response through the API, and we can use promise.any in the situation where we want first successful result ignoring the failures. Now the most common and important example of async and await is for making API calls. So here I have used one uh, API endpoint for fetching any random joke. So this is an endpoint of API which helps to fetch random jokes. You can read about another endpoints also through the documentation of this API, but for now on, we are simply for the demonstration purpose, I am using a simple endpoint which is random joke for extracting any random joke through this API URL. Okay. So here it's wrapped inside try catch block. I've already told that it helps in error handling. And now there is one variable called const response, which is awaiting. So fetch joke is an async function, so we can use await inside it. So the response is awaiting for the fetch. Fetch is basically a promise which contains the URL. So our code will pauses until this fetch will resolve successfully. Okay. So once we get the result in the response, the next line of the code will execute. So the next line is if not response.ok. So it's checking whether the API got failed or not. So if it false, then it simply give an error, printing HTTP error and status code. And then next line, we are extracting the data. Means response is basically JSON. So in order to get the data, we have to convert it into the JSON form. After that, we can extract any useful information from this data part. And if any error comes in our code, then it will simply go to the cache part and print error fetching joke and the error that we get. Now we will take a look on error handling in async and await. So first of all, why error handling is important. So the APIs that we are working on might fail due to network issues or invalid responses. In that situation, we have to be cautious in our code base and use try catch block so that we can get to know that where the error comes from. And another thing is JavaScript won't stop execution on error unless handled properly. And it also helps in preventing unexpected crashes in our applications. So you can see, so you have already seen many examples where we have used try catch block. So I think you are familiar with try catch block. So the best practice is whenever you use anything, when any API calls or any related things, then you must wrap the function inside try catch block for better readability and maintainability. As we wrap up this session, let's take a moment to reflect on what we have covered. So the very first thing that we have discussed in this session are callbacks, which are the foundation of the asynchronous programming, but that leads to callback hell, which is also known as pyramid of doom. And we have solved the problem of callback hell through promises and promise chaining. And after promises, we have studied about async and await, which is a more modern and elegant way of uh, handling asynchronous code. So mastering these concepts would be crucial for real world applications. And thank you. I hope you have enjoyed this session.